Hello, I'm an old guy and I do maths, and as promised in my second video on composite functions, here is the third. And this deals with the third aspect of composite functions. So in the first video we looked at how composite functions are constituted, the order of functions and the terminology surrounding them. In the second one we considered whether, as a result of combining functions into composite functions, certain functions could exist, and there are rules surrounding those. They are basically, for f of g to exist, the range of g must be a subset of the domain, subset or equal to the domain of f, and for g of f to exist, the range of f must be a subset or equal to the domain of g. Now, if that's not the case, the composite function can't exist. And you see this pretty clearly with composite functions where one of the constituent parts is, for example, the hyperbolic function, or a truncus, something like that, or where you've got a square root function of some description. And we have one of those examples here. So the question is, can we make a non-existent function live? Now, I guess the first thing we have to do is we have to establish that in one form or another, the composite function of these two functions does not exist. So let's have a look at that. So we've got the function of x here, and we've got the function of g here. Now the function of x is 4 minus x. Immediately you become aware on looking at this that x cannot be a number that is greater than 4. Why? Because if we put 5 into this, we're looking for the square root of a negative number, and there isn't a real solution to that. If we look at this function, so that's the domain. The domain in this is restricted, and therefore the range. But the important thing is the domain, in this example anyway. If we look at this, there's no restriction on the domain or range of this function. This is a straight line function. Its domain and range run from negative infinity to positive infinity. I suspect there's a problem. And so I note further down the page that f of g is not defined. Why is it not defined? It's not defined because this is our rule. The range of g must be a subset or equal to the domain of f. This is basically all real numbers, domain and range. This is not. So that's the news. The range of g is not a subset or equal to the domain of f in this case. So what must we do? Well, we must consider the rule, which I have written out in English here. The range of g of x must equal or be a subset of f of x's domain. So just to drive this point home, range of g must equal domain of f at the very least. So what we have then is this very simple little inequality here. So what we know is that this is the magic number as far as the domain of f is concerned. And so the potential range of g, the y values, and we know that y is equal to -1, so we can substitute that for the y values. The y values equal to x minus 1, and they must be less than or equal to 4. So, tiny bit of work. X must be less than or equal to 5. In that case, this function, f of g, will exist. Now, the question is, are we creating a new function? Well, probably yes. It's got the same basic characteristics, but it does have a limit. And if you line two functions up and you say that one has no limits and one does have a limit, are they the same function? Well, it's an interesting point. Anyway, let's take a look at what we wind up with. We wind up with a new function for g of x, basically, which we'll call h of x. But you'll notice that the domain of this has been limited, and therefore, when we rewrite the composite function, which started off as f of g and is now f of h, what we get is this. Just let me put a bracket in there. There should be a bracket in there. So that's g inserted, or h inserted into f. This is what we get. And if we take a look at this, the domain of this new function means that it will exist. Nothing greater than 5 can be inserted in here. We can say that the square root of 0 is 0. All negative numbers will work, and so we can say that with an amendment to the function, to the limits on the function, the original function, we can make this function exist. Question yes or no, whether it's a new function or not. That's kind of academic at the moment. What we have done is by limiting the range, effectively the range of g, we have made that a subset of the domain of f, and therefore the function now exists. And that's the end of the third part of composite functions. I thought it wise to divide this into three pieces because there are sort of three main aspects to this. How do you compose the function? What are the rules for its existence? And when a function doesn't exist, can it be made to exist with an amendment to limits on potential domains and ranges? Okay, well, thank you very much for watching. If you found this useful, please subscribe, and I will see you next time. Bye.